So we're going to talk about domain and range today, which is another part of identifying functions. So last class we talked about just deciding if something was a function. Now we're going to look at whether or not we're going to classify like the x values and the y values and look at the inputs and the outputs of the function and how things are related. So when we talk about domain and range, your domain is your x values. In a function. You might notice it says independent variable, so you've talked about this probably in science class before. A lot of situations when we get to talking about like real world functions, a lot of times they have to do with things that you guys look at in science. So our domain or our x value can also be known as our independent variable, which is normally time or something like that that we can change. The range is just a fancy math word for y value. Or this is the dependent variable. It depends on what we're plugging into the function. It depends on our x value. So what we're going to be looking at today is you're just going to be telling me what the domain of the function is and what the range of the function is. So you'll be picking out what the x values are and what the y values are. So what we can see, if I look at the first example for this, I can give you a table just like I did before when we wanted to know what if it was a function or not. So now I can give you that same table and I can say, okay, find the domain and find the range. So if I'm going to write the domain for this first graph, all I'm going to do is write out the x values that I have. And I know by looking at the table that my x values are 0, 1, 2, 3, and 4. So I'm just listing my x values. If I want to write my range, then I'm just going to list my y values. And when I look here, I notice that all my y values are 8 when I look at this. So I don't have to list 8 5 times. I can just write that my range is 8. So if a number repeats, I don't have to write it multiple times. No need to write repeating. So I'm only going to write a number, even if it shows up multiple times, I'm only going to write it once when I'm listing my range or listing my domain. The other thing I want to make sure I'm doing is writing my numbers in order, just so that it's kind of organized and it's easier for other people to read my work. So I also want to write my numbers in order from smallest to largest. So if I look at my second example, now I notice my domain, all my x values are 8. So my domain for the second one is just 8. But my range is 0, 1, 2, 3, and 4. So range. So they're just basically big fancy words for x values and y values. Not too bad? So then the next thing I can give you is I can give you those maps like we talked about last time. And my maps just kind of are my circles with my arrows that connect my numbers. And I can ask you the same question. I can say, what's my domain and what's my range? And I think, even though the maps were a little bit harder to tell if they were functions or not, I think they're easier to tell the domain and the range because they've already grouped all the x values together. They've already grouped all the y values together. We just have to list them with the correct names. So if I look at the first one, my domain is just everything inside this first bubble. So I'm just taking the 1, the 2, and the 3. Those are my x values. My range is the second bubble. So it's that 8, now we can't see it, the 8, the 9, the 10, and the 11.
Mrs. Tachapa,
Yes.
can I use the bathroom real quick?
I guess so.
Thank you.
So I'm just taking my numbers and I'm grouping them together. 8, 9, 10, and 11 were my y values, so that's why I'm picking those to be my range. What would my domain for the second one be? I'm just going to look at that first bubble and I want to pick out my x values from that first bubble, which I see are -1, 3, and 11. My range, just my y values, so my 4 and my 15. So sometimes I might have the same amount of numbers in my domain and range. Sometimes my domain and range might even be exactly the same, or they can be different like the ones we saw. So it's all going to depend on the situation that they're giving you, but you could end up having the same answers for your domain and range sometimes, or like we saw before, you might have one number for your domain and lots of numbers for your range, or vice versa. They don't have to match. Ready for me to move on? So then we can also give you, so you can see it a little bit. We can just give you ordered pairs and ask you to pick out the domain and range. And it's still the same thing. You're still picking the x values and the y values and listing them out. So if I were going to find the domain for the first example, I've got -2, 5, -1, 8, 0, 6, 1, 6, and 2, 7. So the first thing I'm going to do is look at all my x values, which are my first numbers in my coordinates. So I'm going to take -2, -1, 0, 1, and 2. That's going to be my domain. -2, -1, 0, 1, and 2.
Mrs. Tachapa.
Yes.
So the domain is the x and the range is the y.
Perfect. Exactly. Yep. So it's just basically fancy vocab words asking you to pick out the x values and the y values. So then if I want to look at my range is going to be my y values, so the 5, 8, 6, 6, and 7. And I just want to make sure that I'm writing those in order from smallest to largest. So I'm going to put the 5 down. Then I'm going to put the 6. I don't need to write the 6 twice, even though there are 2 6s. I'm only going to write the 6 once. Then the 7, and then the 8. So I'm going to do the same thing with the second example where I have -2, 0, -1, 0, -1, 1, 0, 1, 1, 2, and 2, 2. If I want my domain, I'm going to pick out all of my x values, -2, -1, -1, 0, 1, and 2. And I notice that they're already in order for me, which is nice. So I have a -2, -1, 0, 1, and 2. And I don't need to write that -1 more than once because I've already said it exists as an x value, so I don't need to list it multiple times. And then for my range, or my y values, I see that I have 0, 1, and 2. How do you feel about that? Good? Okay. So now the last part, just like with functions, when we could look at the graph and use the vertical line test to decide if it was a function or not, we can also be given a graph and they'll ask us to tell us what the domain and what the range is. So when we look at a graph, instead of just listing the numbers, we're going to use inequalities in order to say, okay, we have all the numbers less than 5, or maybe we have all the numbers between 1 and 2, things like that. So anytime you're given a table or a map or just a list of numbers or ordered pairs, you're just going to actually write out the numbers, the x values, write out the y values like we were doing. But when we look at graphs, if the graph is just a bunch of points that aren't connected, then we're going to do the same thing. We're just going to list out the x values and list out the y values for the points. But if the graph is like the second example where they're all connected, then we're going to use inequalities to do that, because when they're all connected like that, it's saying we have all the numbers in between those two endpoints. So we could be there forever listing all those numbers, and we don't want to waste our time doing that. So we're going to just use our inequalities that we know all about in order to do that. But if I look at this first one, I see that I have a point. I have a point at 1. I have another point when x is 1. I have a point when x is 3. When x is 5, 6, and 8. And the way I can tell that is I'm looking at my x values. So 1, 2, 3, 4, 5, 6, 7, and 8. And I just want to know where those points fall for my x values to write the domain. So if I'm going to write the domain for this graph, because it's just a bunch of points, I just have to list the numbers just like I've been doing. And then I'm going to look and say, okay, I do have points at 1. So 1's going to be in my domain. I don't have any points at 2, so I'm not going to include 2. I do have a point at 3. So I'm going to include 3. There's nothing at 4, but I do have a point at 5. I have another point at 6. 7, there's nothing. But then 8, I do have a point. So 8's going to be in my domain too. So I think the graphs are the trickiest ones because when we want the x values, we want to know up and down which way they're going. You can also, if it makes it easier, you could go in and write the coordinates out for each of those points if you wanted to. But I like to just look at the graph and kind of see how far over they are and then use that as the x value. So now if I wanted to do the y values, or if I wanted to do my range is going up the side. So 1, 2, 3, 4, 5, 6, and 7. And I want to see, okay, I do have a point when y is 1. So in my range, I have a 1. I have 2 points at 2. So I'm going to include 2 in my range. I don't have anything at 3. When I draw a line at 3, I don't see anything. So I know there's no 3 in my domain or in my range. I do have points at 4. So I'm going to include 4. And I have a point at 5. So 5 is going to be in my range. Do you want to see another example like that, or do you feel okay with that? You're good? Okay. So now the only difference with the next one is that I don't have separate points. I just have one piece of a graph, or I have a line that they're kind of drawing there, and all of those points are connected. So for my domain, I want to know the first x value on my graph and the last x value on my graph. So I want to know where it starts and where it ends. So if I look at my domain, I see that my graph starts at 0 and my graph ends right here at 7. So my graph is in between 0 and 7. My domain is talking about my x value, so my x is in between 0 and 7. And then since those are closed circles, just like with your inequality graphs, because they're closed circles, I'm going to use less than or equal to signs. So that tells me that x is in between 0 and 7, and I'm including 0 because it's a closed circle, and I'm including 7 because it's a closed circle. So 0 and 7, my first number, my first x number, and my last x number. And then because they have closed circles, I have those equal to signs. So that tells me everything between 0 and 7. Instead of me having to write 0, 1, 2, 3, 4, 5, 6, 7, 1.5, 1 3/4. There's so many numbers in between there, I'd be there forever listing them all. So instead of having to list them all, I can just say, okay, use all the numbers between 0 and 7. If I'm talking about the range, I'm going to do the same thing. I want my y values. So I want my first y value and my last y value. So if I'm looking here, let's see, I've got 1, 2, 3, 4, 5, 6, 7. I see that my graph starts at 2. So my first y value, or the lowest y value, is 2. And then my graph keeps going up until it gets to this endpoint, and my endpoint is at 4. So my range ends at 4. And then same thing, because these circles are both closed circles, they're both colored in, both of those endpoints are colored in, I'm going to use less than or equal to signs. And I want to use the less than signs because that's telling me that y is in between 2 and 4. So you're always going to use those less than signs when you want to be in between a number. And then you're always going to use where it starts and where it ends. And this is your classwork is going to look a lot at just looking at the graphs because I think that's the trickiest part. And then your homework is going to have a practice of all of them. Do you want to see another graph where you have to write the inequalities? Yeah? Okay. So if we look at this next one, this like curve that they're giving us, now I want to look at my first, I still want to look at my first x value and my last x value. They also just use the entire coordinate grid. So remember, this is 1, 2, 3, 4. This is -1, -2, -3, -4. I can zoom in so you can see it better. So if I'm going to write my domain here, I still want my first x value and my last x value. So when I look at this, I notice that my first x value is right here at -3. And my last x value is at 1. And then both of those circles are colored in, so they're closed circles. So I'm still using my less than or equal to signs. My range for this one is a little bit trickier because I'm not just looking at my endpoints. I want my lowest x value to my lowest y value, sorry, to my highest y value. So when I'm looking at this, the lowest my graph ever goes is right here. That's as low as it goes if I'm looking at it. So that's where I want my range to start. And when I'm looking at that, we're going to pretend I drew a better picture. And we'll say that that point is at 1, 2, -3. So my range starts at -3. And then I want my highest point. So I keep going up, I'm looking, and my highest point is right here. I don't have any part of the graph that goes any higher. So my range goes 1, 2, up to 3. Range is my y value. And those are still closed circles, so I'm still using equal to signs. What are you thinking about this part? You like bring back the tables? Bring back the ordered pairs where I can just pick out the x values. Do you want to see another one? Yeah. Okay. And then we can work on your classwork together too, so that you can get a better hang of this, because it is a little tricky. So if we look at this next one, I have a graph. It's just a straight line. It starts at the point -3, -2, and it goes up and on forever. So a graph like this where I don't have two endpoints, where it's going to just kind of keep going forever, that arrow tells me it's going to keep moving forward. I just want to know where it starts, because it's never going to end. So I'm going to look at this for the domain. And I want to know where my graph starts, which is right here, at -3. So I'm going to say that my x values start at -3. And are they bigger than -3, or are they smaller than -3? I'm going to end up having, this is going to be -3, right? -2, -1, 0, 1, 2, 3, 4, and it's going to keep going and getting bigger and bigger and bigger as it goes to the right. So my x values are going to be bigger than -3 or equal to -3. If my graph was pointing to the left, then my x values would be less than -3. My range, or my y values, the lowest my y values ever go are right here, which is at -2. So for my range, I'm going to say my y values are greater than or equal to -2. So that for when I draw that graph, I have all numbers -2, -1, this is 0, 1, 2, 3, 4. I have all the numbers bigger than -2. This is a super tricky idea to get used to. So if it's making your brain hurt a little bit right now, don't feel overwhelmed, and we're gonna get you through it. Are you okay with me changing the slide so that you can see your classwork now? Okay.